Now it's our main attraction. Now I would like to introduce Professor Dr. Saleh A. Tanveer. It's my pleasure to introduce Professor Dr. Saleh A. Tanveer. Dr. Saleh A. Tanveer, a very renowned mathematician, works as a professor at the Ohio State University, USA. Prior to this, Dr. Tanveer was visiting fellow, Institute for Mathematical Sciences, Imperial College, UK, visiting professor, Department of Mathematics, the University of Chicago, Vice Chair, Department of Mathematics, the Ohio State University, and several other positions in USA. He received his PhD from California Institute of Technology, USA. He has been actively involved in research and teaching for more than 2 decades. He has published more than 75 articles in referred journals and presented his research works in various conferences. He received several honors and grants, awards including NASA grants, NSF grants, Frankel Prize given by American Physical Society, and Simon's Visiting Fellow. He was a fellow expatriate of Bangladesh Academy of Sciences in 2019. He also involved in editorial and professional activities such as guest editor, Journal of Fluid Mechanics, co-editor, proceedings on asymptotes beyond all order, etc. He has supervised more than 13 doctoral and postdoctoral fellows. His research interests include asymptotic free boundary problems, partial differential equations, and fluid mechanics and turbulence. Let us welcome Dr. Tanveer. Please, sir.
Thank you all. This is supposed to be a non-technical talk, so I was hoping that people outside of mathematics, particularly consumers of mathematics, not necessarily in the math department, will have something to gain. By the same measure, students of mathematics probably will be, because I won't have as much time to talk about mathematics itself, you might be a bit disappointed. Anyway, I'll try to make compromises and make it interesting on either front. So the nature of mathematics and its role, that will be the role in human development in Bangladesh in particular, will be the topic of my talk. So I've organized my talk in the following manner: talk about impact of mathematics and its appearance in different guises, and a comment about what is the nature of mathematics and what is the connection between mathematics and other sciences, and of course, engineering. I'll also talk a little bit about mathematical science generous people with vision. Moneyed people with vision can also contribute to what I'm going to lay out for you. So, just a second. Yeah. All right. Every area of science and engineering, and increasingly social science, depends on mathematics. As soon as you start from go beyond qualitative understanding, you need mathematics. For instance, you could say this thing is hotter than this thing. That's qualitative understanding. But a famous mathematical problem, whether P is equal to NP, that has a direct bearing. If indeed that is true, it has a direct bearing on how much security you have, right? So this is, I'm connecting a research problem at the highest level with something very practical, whether the money you're sending will be secure or will remain secure, or you have to look something somewhere else. In medical imaging, such as CAT scans, well, we do it, we go to the doctor and they give you, you do CAT scans, but you don't think about what goes on in terms of imaging. And there is something called radon transforms, which are used. In most of this, you don't really have to know the mathematics to use it. Of course, if you want to make progress in these modern areas, you need to know mathematics. You might take the view that we are in a third world country and these things are going to come from abroad, so we really don't need to know all these things. Well, the next set of slides, next slide, gives you much more practical, down-to-earth applications of mathematics. Suppose you have a storm, you have a cyclone coming in Bay of Bengal, and you have to predict the height of the surge, the tidal surge and tidal bore, because that allows you to say which areas you want to evacuate, right? So that relies on modeling. It's a fluid dynamical modeling that you have to do. Epidemic modeling, as we have known, if you have to do it properly, you need mathematical modeling. And if, for instance, you want to know, you have limited resources, what areas, how should the intervention should work with maximal effect? That does require modeling, though it's not perfect because there are certain factors which are unknown. It is a moving target around. So you are running a bank or some other business, and you want to know how many people to put in what counters, right? That's an optimization problem, and that's a queuing theory problem, and it involves probability, which is an area of mathematics. People building security from scratch in Bangladesh, but you certainly need the expertise to know how vulnerable your system is. And to determine this vulnerability, you have to know what goes into this encryption code. For instance, all these filters, some of them homegrown in arsenic, for arsenic filter. And we want to figure out ahead of time what should be the lifetime of this filter. You cannot wait for 10 years and then find out it's not working, or because that it has health hazard associated with it. Well, my colleague one of my colleagues at Oxford, here's a YouTube link, has actually done research to figure out the predicted lifetime of arsenic filter based on certain parameters. So this is a very down-to-earth use. We also have, at a very basic level, look at some of the subjects. Mathematics appears in many different guises. They don't all come under the label of mathematics. So I like to call it mathematical science more generally. Computer science, one of the pioneers of computer science is Alan Turing, mathematician Alan Turing. And what did he do? He worked on logic. He was very interested in Gödel's incompleteness theorem. That's logic is an area between mathematics and philosophy. And Alan Turing is known for his Turing machine. And every computer language that comes in has to be Turing complete. If you know about computer science, you'd know what Turing complete means. If you're an economist, you must have come across Nash equilibrium, which was discovered by mathematician John Nash, the subject of The Beautiful Mind. What he actually came up with, this Nash equilibrium, was actually an application of functional analysis, which is an area of mathematics. Einstein's general theory of relativity relies on Riemannian geometry. Riemannian geometry was due to Riemann, Bernhard Riemann, German mathematician. This is an area of mathematics. Whether it is Big Bang theory, quantum computers, computational chemistry, people in multi-atomic system, they're very interested in calculating band gaps and all these things. They use density functional method. These are all mathematical machine limitations. These are right, and so these are all have advanced mathematics at its heart. The same is true, as the Honorable VC and mentioned. Same is true in most areas of engineering. In social or medical sciences, of course, we have increasing use of mathematics. But of course, in those areas, it is constrained typically because the assumptions cannot be checked in, just in physics, for instance, you can do a controlled experiment. You cannot do a controlled experiment with humans. And so human behavior is harder to predict. About adding and subtracting numbers or mastering rules. That's what we are taught at an early age. You just have a bunch of tricks. You do this, you bring this to the other side, you go through this. No, all of these operations that you are doing have very logical structure to it. You start in a pure and everything else follows, right? As one after the other. This development of mathematics, how mathematics at the fundamental level, how it applies, it contrasts with the other sciences, other physical sciences. How? Because in the other sciences, it's an interplay between observation, experiment, and theory. You create a hypothesis, you predict something, you go to the field and see if you observe what is predicted. If not, you come back, you modify your theory, and so on and so forth. This is a go back and forth. Then you might ask, why is it? Okay. So if the mind game. You start with some axioms and you end up with some conclusion. In the other case, it's what you see in the world around you. That's the basis of your sciences. So the question then comes in, why is it that mathematics is so unquote unreasonably effective? Quoting famous mathematical physicist Eugene Wigner, why is it mathematics is so unreasonably effective in the physical sciences? That's a very good question, and it's a deep question. It's because of the nature of our universe. We only have a few fundamental motion, Newton's law of gravitation. And if you take Newton's law of gravitation and combine it with Newton's law of motion, you can come up with Kepler's law of planetary motion. The law of falling bodies is not a different law. It follows from Newton's law of motion, Newton's law of gravitation. So all of physics is encoded on some few basic laws, and then everything else follows as a mathematical corollary, because the basic laws are given in terms of mathematical expressions. Just like theorems follow from axioms, all physics that we see at a more complicated follows from some fundamental laws of physics, just like those fundamental laws are essentially your starting axioms. What is the necessity of mathematics, you might ask? Well, let's look at the picture in an advanced country. There is a report in Deloitte in 2013. Here is the report. If you want to go and look at it, I put the link in there. It was estimated that the net impact of mathematical activities of all forms to British economy was $300 billion per year, and it accounted for 10% of all new jobs. Keep 10% of all new jobs in the British economy in 2013 came from mathematical activities, defined in a broad way, of course. If we look nearer at the East Asian economies, technology is a prime driver, and technical prowess of workforce has been very important. And you cannot develop a proper technical prowess without mathematical abilities, and mathematics training is an essential component. As a country's costs will be lower, so we will lose our competitive advantage. And the other danger that lurks in the horizon is what would happen if artificial intelligence and robotics particularly robotics becomes much cheaper and much more useful you can easily imagine that a lot of the jobs that are done by unskilled labor in Bangladesh will actually become threatened. So this might happen anywhere between 15, 20 years. I don't have a clear vision when this is going to happen, but this is likely to happen. And Bangladesh and countries like Bangladesh will have to prepare for that kind of future. That means we have to use human skills. We have to upgrade our skills, and that includes upgrading the skills, the technical skills, and the mathematical skills of the people, among other things. What are the challenges for mathematics in Bangladesh? There are various challenges, so I group them in 3 different categories. There are because the talent pool, if you don't have sufficiently talented people going into mathematics, so on the overall, there are, of course, lots of exceptions. But in general, if you do not have sufficient talent entering mathematics or allied fields as a profession, that impacts the training of our engineers, right? You want to do a structural engineering, build a huge building and all these things. Of course, much of it is already known. You can go and go for it, but in challenging situations where people haven't looked at with particular conditions or particular challenges, you need to go back to actually modeling those situations. Have forged by linear differential equations that are taught by mathematicians. So be able to understand how mathematics is used outside of mathematics itself by consumers of mathematics, then you have a problem. So the talent pool is extremely important. Contributing to this talent pool problem is, of course, widespread misperception about scope and usefulness of mathematics. What is the learning and dissemination problem in Bangladesh? We have too many subjects that crowd out the schedule of youngsters, our kids. What happens when you have too much pressed on them too early? They look for shortcuts. And what is that shortcut? Cramming and looking for common exams, because that is the way out. We are destroying the minds of younger people at a time when their plasticity of their brain is the highest. There is too much emphasis on learning facts, not so much on reasoning skills. There is little diversity in exams and a low bar on GPA 5, which ascertains little in-depth learning. I came across a Dhaka University student who graduated, did pretty well. And I asked him, didn't you see all these things? He said, well, didn't you learn how to prove things in geometry? He said, well, you really do not have to learn that much because you can get to GPA 5 without learning all these proofs. So that is a sad story. So we have exams, including university entrance exams, that reward speed rather than depth. There is not too many incentives for teachers to teach beyond exam material. And that starts from the elementary level all the way to secondary level, and perhaps a little bit less at the university level. But on the other hand, if you have students who can guess this exam, you have common exam problems that appear every 10th year, then you're limiting the learning of the students. University coursework that I have seen is typically hodgepodge. I'm talking about Bangladesh University. The coursework is typically, especially in mathematics as I have seen them, it's typically hodgepodge, geared towards a teacher's desire to teach specialty course rather than an in-depth treatment of basic material. And that actually affects whether our students in Bangladesh are able to get into good universities abroad, because they look at very basic, training. Do you have enough analysis, real analysis? Have you done enough problems? It's not enough to just read them and memorize some theorems. That's no good. You have to be able to use what you have learned. And that's not reflected in the training that we have in Bangladesh, with some rare exceptions again. Talent pool problem. Some 50 years back, the best students went to study basic sciences and mathematics. That used to be the trend. Even now, no one in the top 10, except the guy who came in 10th, went to engineering or medical science. So the situation has completely reversed. Despite record competition to enter universities, the standards in mathematics appear to have declined, and that's a sad story. I'm talking about overall standards, not, there are of course exceptions. Mathematics is not considered an attractive career option. So if you can't get into, this is generally true. If you can't get into other areas, you study mathematics, even though you're not inclined that way, because maybe you'll take BCS exams and then get out. So as a result, and also the way we have this strange university admittance system that has been developed, you don't have necessarily people who want to study mathematics who are in the mathematics department. I'm talking about public university. I don't know if private universities have done some things better. Undervaluing of mathematics impacts its demand, and it worsens the talent problem that I was talking about. There is also the wider culture, right? The culture of what the guardians perceive as the value of a mathematics training, and what the policy planners at the higher level, what do they think about mathematics? Those have all impact on what I'm saying. Most people in Bangladesh think of mathematics as merely mastery of rules and applications. What is unrecognized is that reasoning from point A to point B through a series of logical steps, that is actually a skill. Western employers and graduate schools of all types have already recognized this. And we see record number of students wanting to study mathematics, even at the undergraduate level. And, we have people going over to business school or to medical school or to law school, and sometimes engineering school, with background with a bachelor's degree in mathematics. We have seen this all the time, and they're sometimes preferred. They're considered hard sciences. If you have studied mathematics or physics at the undergraduate level, you're in demand. You're even in demand in the Wall Street. So, there is this huge demand, and that has a ripple effect on the quality of people going into this profession. And this is not recognized by Bangladeshi employers. And that has a ripple effect on the level of talent that enter mathematics as a profession. Well, I have complained about a lot of things, but there are also there are prospects and there are promises. And they have to be we have to think about how to maximize this. One of my observation is that some Bangladeshi pre-university students, somewhere from some other remote schools, and I met a Sylhet pilot school student studying in Cambridge with a full scholarship. And he's one of those examples, and there are a lot of them who have done very well in an international competition. With some of those problems would trouble a professional mathematician. So we have the shining example of Bangladesh International Math Olympiad team under the guidance of Mahbubur Rahman of BRAC University. They have done very well. So this is remarkable. We have students who are performing at the highest level in international competition. Though the numbers are small, there's a much bigger number of students who have been trained and who haven't done well enough to earn a medal, but they're certainly trained in that way. So this means that our students are capable, right? We just have to nurture them, okay? We do not have to destroy their brain by by putting on them burdens like memorization and learning facts and common exams and all this thing. We have to test them so as to encourage their creativity. The kind of success that we have seen in this level needs to be replicated at all levels, primary, secondary, and tertiary. We need a way of attracting and retaining at least a fraction of these best and brightest youngsters in Bangladesh. Okay. What can be done? We can do extensive resource sharing, both at home and abroad, and that can add to student experience. These days with remote ways of advising and things like that, we can imagine very well that you could have people at different institutions. You have the best in Bangladesh and you have other people abroad, and they can contribute to the student experience, or even researchers at different level can cooperate with each other, and that can improve everything, and that could actually improve the overall level of mathematics training. And of course, there are different levels, and some of them have to build on policies. Of course, what I'm saying only works if we have a cooperative rather than a competitive mode between universities and between people. Another thing I have been thinking about, and I think it would be very helpful, is to have institute projects at a smaller level. So there's a professor who has some resource, some money, and then they gets the best student in his or her class with a project. The project is that what I'm teaching now, you go ahead, go to the internet, search for materials that you find you are equipped to understand, and it adds to your knowledge, lateral knowledge. And so you get all these group of students, each one looking up material on the internet, and then the instructor, of course, will not have as much time to check through the whole thing, but will check randomly and determine if what the best students have found out, if that's appropriate. And therefore, you add those links as part of your lecture, okay? So why is that very helpful? Think from the viewpoint of a student or a young researcher. You don't know if you're going to spend half an hour listening to some online material at MIT and then find out that after 10, 15 minutes, you don't understand anything because you don't have the background. But if someone provides you a map of online material at the level you are at as a student, then your search on the internet is very narrowed. You don't waste a lot of time. Okay, so this map of online material is a very worthwhile project, in my opinion, and this will immensely add to student experience. And I think universities who have some resources to do it, it is not going to be a particularly expensive project. It will help, actually encourage youngsters who are bright to participate in this, and it will really help. Mathematicians and consumers of mathematics need to be better coordinated. Honorable VC mentioned that we have consumers of mathematics and engineering and in social sciences and many other fields, and there are mathematicians who are teaching those courses. Imagine that you have a course where you have a joint responsibility of teaching them. The electrical engineer is working with some transfer function, or is looking at stability of some circuits, and the mathematician is there teaching differential equation and Laplace transforms, and is not aware of these other areas. If you two together come over and sit down and then try to understand each other's language, then you could actually have a cooperative way of having a course which actually combines the tricks on how to solve problems with the actual experience of seeing how they're used. So imagine this thing, this kind of thing, joint thing. Other thing you could think of is double major offerings with allied between mathematics and other areas. And this will really help. What else could we do? We can think of university entrance exams. We need this. Currently, I understand that, I don't know if this is true in private universities, but it is certainly true in public universities. You need to study mathematics and you take a exam which has English and it has all these other sciences and then mathematics. And then depending on how you do, you get your options. So I don't know who came up with this idea, but it is a completely, if you ask me, it's absurd. Think about the student I met in Cambridge in 2019 when I was there from Sylhet Pilot School. He told me that he wasn't sure he would get into Dhaka University. I said, why? Because he didn't have a GPA 5. And he had some weaknesses in English and some area. So I thought to myself, he is good enough to get a scholarship in Cambridge and not good enough to get into Dhaka University. So we have got to do something to remove this absurd situation. Admission tests, this is something that administrators can do. Admission tests should be less about speed and more about depth of learning. You cannot do it overnight because there is student expectation, but you can do it gradually. You have an aim in a 10 years time, this is where I'm going to go, okay? If you try to do things abruptly and you don't have the manpower to do it successfully, this transition, then you create more headaches and then the whole project reveals very little value. Avoid repeat problems from exams from year to year. Also, well-performing students in international math Olympiads, even if they haven't won a medal, but if they won at the national level, they should have a way to get admitted to mathematics department without having to take all these exams in all these other subjects. These international Olympiads, believe me, these are very deep problems. They have 6 of them. You have 6 hours to solve them. They're very difficult and it requires a lot of training. And this is not the kind of training that you just bring one on one side and you do manipulation. It just requires a lot of a thought process. So a student of that kind or that caliber who has done well should be able to get into these universities without having to take these exams. And I think Shahjalal University and Brack University already follow that policy. Other universities need to come along. Mathematics, university entrance, I mentioned that. Admission test, I mentioned that. Avoid repeat problems from year to year. Mathematics curriculum at the undergraduate level has to be about basics, not some, you teach a mathematics class and then you teach a course on relativity. That's something that can pick up later. At the undergraduate level, if you have to teach analysis, make it a 2-semester course, make it more rigorous, make them do a lot of exercise. If you say you don't have the right kind of people to teach them, then do it slowly, make a transition. Try to understand what kind of people you need in order to teach it at that level. If necessary, cooperate with other universities which have the right personnel. Now, a BSc in a subject like mathematics, in a subject like mathematics, the BS offering, this is a very basic subject. BS offering should be there at every university, private or public. You could start off small. You could have programs with double majors with other things, which adds value to you think of electrical engineering applying abroad. If he or she has a electrical engineering degree with a minor or a double major with mathematics, that actually helps them even more. Okay. And it helps the math department because then they have, half of another student. And that way you can build your department and you can attract quality people. And that will actually help get more and more talented people into mathematics. Include some items, of course, in mathematics curriculum that relate to communication skills. And I also believe a good university must have good research profile. Board of trustees need to be mindful that putting a huge number of course load to attract and retain brightest researchers, we have to have reasonable course load so that best and brightest researchers stay around and you are able to attract them. Now, this is important because we have many, I don't know about Ahsanullah University, but I certainly know of some private universities where the Board of Trustees member look at universities as a cash machine. So think of the best universities in the US, which are all private, and think of the people who created them. Carnegie Mellon. Carnegie was not such a nice guy. But then at an old age, he decided to leave something for the society. And he had this vision and created this world-famous university. Think of John Harvard. You have all these other people. They left something for the society and then had this vision. This is what's going to happen. We do not see that in Bangladesh, not in a big number. Financially well-endowed people with vision need to follow the example of Jamshed Tata, who created the Tata Institute of Fundamental Research. This will help retain some of the best minds, and some of the people who are going abroad can come back and do something useful instead of getting into the politics of all these people and people trying to push each other out. We need to take care of the environment so that they flourish. Well, example, I want to end with just one example. What can be done, right? Or if you have a talented mathematician, and I give the example of Mahbub Majumdar of Brak University. Look at the variety in the student thesis of Mahbub students. You have a thesis on, this is only in 2017. The first thesis concerns secure data transaction. All right, that's certainly a part of computer science. The second topic is field theory and gravity, which is part of theoretical physics. Black hole information paradox, that's part of astrophysics. Quantum information channel, that's part of quantum information sciences, which is becoming more and more popular because with the advent of quantum computers, this will be actually a very useful field. Then you have another one which predicts stock market. Well, that could be that's a financial mathematics and business school subject. There's another one involving analysis of quantum algorithms. Again, it has quantum algorithms is something that will be useful in quantum computers. There's also a topic on machine learning, right? And then chatbot. And chatbot, if you don't know what chatbot is, if you go to a bank, log into a bank and want to seek help, you are usually greeted by a bot, which is basically artificial intelligence, and they try to answer your questions to the best of their ability. And that's certainly an area in artificial intelligence. So you look at this whole variety, and this is all coming from these are thesis students of just one person who's extremely talented in Bangladesh. And there may be others, but I don't, imagine that all these people who are coming from math Olympiad people, a lot of them are going to best universities abroad. If we are able to create a situation of being able to attract a fraction of them back to Bangladesh, think of what can happen in terms of dissemination and overall impact. Conclusion, mathematics is at the heart of all areas of physical science and engineering. Proper mathematics dissemination requires critical level of talent. Mathematics is important for skill upgrade as Bangladesh graduates from a low-skill, low-wage economy. Mathematics training cannot be just about learning and memorizing rules. There must be much more exposure to the logical aspects of the subject. Universities can seek to strengthen quantitative background of its students through cooperative arrangements with other universities at home and abroad, and directed use of online resources, just like the map I was talking about. There has to be greater integration between mathematics and other allied areas, and it's very desirable. And I gave you a shining example in Bangladesh itself, just to see what is possible. And we need to think about conditions for replications that need to be created for significant multiplier effect. And I certainly think a mathematical institute created on a private initiative would be a great start. And I mention private initiative because I don't trust that our politicians will keep politics out of such appointments. So let me end with that. Thank you.
Okay, thank you so much, sir, for your nice and informative talk. Although I am not mathematician, but environmental chemist. However, I use mathematical modeling in my research studies. Previously, it was unknown how pollutants bind to the surface, but we have been able to identify using mathematical model that now cationic pollutants bind to the surface, forming both outer sphere and inner sphere complex depending on solution pH. I think this talk is very interesting and all participants will be benefited. Now the platform is open for questions. If you have any questions, please feel free to ask our honorable guest. Please, anybody.
Can I ask, sir, it's Hakim from Buet.
Oh, hello, Hakim.
Sir, how are you, sir? Sir.
Fine.
Sir, I have just concerned one thing. Our students still do not know that math is a language of science, technology, and engineering. I don't know how to overcome this scenario. One particular question to you, in our medical science, do you think we need to emphasize more on math in our medical curriculum? I don't know. Yeah, I just want to know your opinion. If you know our medical science curriculum, then you can answer, sir.
Yes, to some degree, that's true. Because imagine you have all these different, people actually. I'm defining mathematics in a broader sense, mathematical sciences, and that includes statistics and things like that. So one of the problems that happens is you have all these different kind of tests done on the efficacy of medicine, all right? Or in the occurrence of some disease, or the cross correlation between different factors. In order to get an educated guess of which studies they should pay more attention to, you need to actually know a little bit about how you create a representative sample. What is a representative sample? How do you determine a representative sample? How do you study the statistics? How do you figure out how many, what should be the number in the sample so that you get 95% confidence level in your conclusion, right? So all these things if you have a person in the medical field and they're looking at all these different claims of different efficacy of medicine or all these different diseases and then different causes, and then they're looking at this study done abroad and they're not quite sure what is related to what. If you want to be at the forefront of this area, you have to have a quantitative understanding for sure.
Yeah. One simple thing that our reference value for blood pressure, we know that 80/120 is the standard reference value for systolic and diastolic. That's the thing. I don't know if you have any idea where does it comes from. I mean, this reference value, is that from the statistics or from the physiology?
Yeah, I'm not a physician, and
no.
I think basically, as far as I know, if someone is more educated, please on this. As far as I know, this is basically people actually look at statistics of people and
yes.
and average over all these things.
Yeah, regression fit.
And then determine that what should be what, and then they look at different factors for a health. How do you define a healthy person? If you have absence of these symptoms, you're declared healthy, and then you average over a certain number of people, and then you determine that a healthy person should have this value in their pressure and this value in their heartbeat and things like that. Right?
Sir, my concern is there that if it comes from the Western, I think Australia or America said 200 years back from the statistical point of view. So does it go for our people if we don't have any?
Yeah, you point out a very good question. I alluded to that at the beginning of my talk, which is in social sciences, and I should have also included medical and biological sciences. When you do not know the underlying factors, when you do not know for sure if there is a cross correlation with the race of the person and things like that. So then, for instance, drinking milk is a good idea, but we have Asian people, we have a problem with lactose intolerance, and therefore it is not a great idea to have a huge number of bottles of milk. So this was not known. So you can have other factors that come in and which is not known. So in the averaging, when you decide on what a good sample is, if you do not know all these other factors, maybe racial factors, all these things that come in, so your average number may not work well with subsample, with subgroups of that sample.
Okay, sir. Thank you, sir. Thank you.
Okay.
Hello, assalamu alaikum, sir.
Okay, next, please.
Hello, assalamu alaikum, sir. My name is Aminulchem. I have a question. Is particle physics a good choice for a research career?
I mean the question is I'm not the right person to ask, because I don't do.
Okay. So next is how to get a full free studentship in foreign universities like USA, UK, or in Japan. Can you please help me? I want to get a MSc in math or physics. Please.
Can someone has the okay, yeah. So typically what happens is you have to these days it's a lot easier. You go to a university department website, or you could just Google and you say mathematics or physics, some university, studying physics at Ohio State University, which is my university, or studying physics at some other university, all right, at Harvard University. You Google that, you put those key things, it will immediately take you to a web page. And then you'll see all these things, how to get in. at least in all the respectable universities that are here abroad at the graduate level, if you actually get admitted, you automatically get full financial support. All right. So there is no problem with financial support. They automatically give you, provided you're good enough to get into those programs. So you just follow what the procedure necessary to get in.
Okay, next one is
Many thanks, sir.
Mohin Uddin. Are you there, Mohin Uddin? He has made a comment. Please, sir, give some suggestion for mathematics student willing to go abroad for higher study.
Yeah, so there are basic things. So in most mathematics syllabus, they will teach you stuff like maybe real analysis or something like that, and you're used to memorizing some of these theorems, but you don't know how to do some of these exercises because you're never asked to do them. Your teacher didn't ask you, and this is the situation in most Bangladesh universities. Judging from my experience with some Dhaka University students, that's certainly true. So what you could do is go back to those books, look for standard books, like if you are studying for graduates, if you want to make sure you get into a good graduate program, not only get into, but also survive the program when you pass the qualifying exam. It's imperative that you actually have good background in analysis, and if you are a bit more peer-oriented, also a good background in algebra. Analysis and algebra are the fundamental things, roadblocks to passing the qualifying exams. But you are usually taught PhD level real analysis class, which involves measured theory and all these things. But if you're fundamental level, which is the so-called baby Rudin book, RUDIN, that's the standard book that's used in many US universities. You make sure you know how to do those exercises, and these days you have access to all these online stuff which does all these things. So you could attend some of the online lectures at MIT, for instance. If you don't understand at a certain level, it's not good enough to sort of understand. Mathematics is something which is all or nothing. If you understand, you really have to understand. You know how to actually do things and understand in a basic way, in a deep way. That would be my advice.
Okay, anybody else, please?
Sir, I have a question, sir.
Yeah.
So, sir, basically, a few days back, I was watching a lecture of Marcos de Prato. She is a renowned financial economist, and he just said that even DeepMind has come up with this theory that machine learning can be heavily used in mathematics, where previously mathematicians used to use proof techniques and to find the connections. But now machine learning is used to detect the patterns, and then after the patterns are detected, mathematicians are proving them. So it's basically going back, going in the opposite direction. And if you are exposed to this area where machine learning is used in mathematics and the proof of it, then how do you see the future of this field?
Yeah, so what happens is computational, so the basic computer technology is essentially algorithmic. You start with the algorithm and it follows. And now, of course, when it comes to machine learning, your algorithm is at a higher level, where it is able to, the algorithm is about taking in the data and then assimilating it based on certain rules. All right, and that becomes the memory of the and as it is exposed to more and more data, it is stored. So it's more like human being. We look at things, we ingest it, we have experience, and so how you'd act under certain conditions depends on our experience. So this is in machine learning, when you have these, semi-intelligent robotics and all these things, you start with algorithms at a higher level, meaning not at the level of, if you have this, you do this. It's more like creating a structure on how it will act, and that structure depends on all the previous inputs, all right? So it's a bit more complicated. So what can happen is, it is my view. I mean, I don't know. I'm not an expert in that. Only going to be that routine things that we do in mathematics. So we establish this other that can act into an algorithm and eat them. Machines can also look at the pattern and then decide whether or not something is useful, and that's already of the type. Like, for instance, when you there is a 4-color theory initially proved by one of my colleagues at Ohio State University using when you in combinatorics and many other areas, if you figure out all possible and steps, those could steps and the computer to check them. And when it's high, there are many steps and many things to check, but each of those checks are routine. Those are the kind of activities machines can do. But when it comes to extremely creative things, there will always be that he went to Brack University and decided to use, so there are cases like that. So what's important is you keep in mind the students can look at syllabus, or everything at universities, a good universities abroad, you can look at what is being taught there. And then usually the websites also give you text, so you have some ideas of what is, and some of the text may be old and available free online. So, and some of the teachers put all the notes up for free. I know some of my colleagues do, and you can download those notes and follow and do some of those exercises. And you can do, if you are self-motivated, there are ways that are available
Where I
now.
can find it.
There are ways, there are opportunities available now because of so many things are online. Then you have many more opportunities. So keep in touch with what is being taught abroad and what kind of skills are necessary. And then that way you can approach anyone abroad and do a little project here and there, right? So typically what happens is you find out something and maybe write an email to a professor that I learned something. I wonder what would happen if this was this. If you start some conversation, most of the professors are very busy and will not return your email, but some of them might actually take an interest. And that's one way you can establish contact with other people. But you have to be aware what is being taught and what is a good way of getting there. So you have to know your destination and you have to know how to get to your destination. And one way to start that is you look at the syllabus of what is taught at good places abroad. And from that syllabus and from those texts, you know what you are expected to learn, and then find ways of learning them by using online material and things like that. At a lower level, even first year undergraduate, Khan Academy is a decent start. It doesn't do all the proofs that are necessary in linear algebra, for instance, but in terms of computational skills, it's fairly good, even at the first year level when you're learning tricks of differential equation. But it doesn't go through, for instance, proofs of why there are solutions and things like that. So, you know, you have resources abroad, and you look at you can look at them. You know. And of course, you know, it would be good. This is from your side, and then it would be good if your teachers or your universities make available resources from other universities in Bangladesh. You may have a joint like lecture session. One university can have a sharing agreement at the level of the VC, that certain courses there taught by some well-respected teacher who are very good in communicating their skills, that their lecture is available to the other university. In return, maybe the other university has a very strong department, some other department, and they have a famous lecturer. They could actually offer the same thing. So you could have a cooperative agreement where everybody is a winner, because students are given a much bigger share of the resources than that would be available directly through them. And then you could combine them with expertise from abroad who you know, it's not realistic that the people abroad will start teaching you, because they have their own responsibilities with their own teachers. But once in a while, you could have, you know, expository lectures series, you know, 3, 4, 5 lectures on certain areas. How do you start from that? You know, why is it that I mentioned that? Why is it that Newton's law of gravitation and Newton's law of motion imply Kepler law of planetary motion? I assume you know about Kepler law of planetary motion. Planets sweep equal area in equal time, and all these things. So all these laws, how do one come from there? That's something we teach to our honors first-year students. Honors meaning the better students rather than the regular students. So we show that derivation. So you could have special lectures where you get entertained. You get, how do you actually have you're teaching a linear algebra course, you bring it into a problem from electrical engineering of circuits, you try to solve them, so you immediately see how you can use them. So these are some of the things. So you could have experts abroad, and they don't all have to be housed in mathematics department. There are very talented people in engineering who have good knowledge of Routh Horowitz theorem, who can use it for figuring out stability of electrical circuits. And Routh Horowitz theorem is basically a mathematical theorem about properties of zeros of functions. And so those are things that can be combined together, both from the practical useful aspect as well as the mathematical aspect.
Okay, we can take last question. Last question.
Dr. Aminul.
Yes, sir.
Dr. Aminul, ওই chat box এ অনেকগুলো কোশ্চেন আছে, do you have a time to look?
Sir, already some of the questions have been answered by our honorable speaker. Most of the questions have been answered.
Okay.
Someone is raising their hands.
Okay. Last question, please.
Mr. Shakal Roy, can you hear me? Mr. Shakal Roy.
Yeah, I can hear you. Can you hear me? Can you hear me, please?
Yeah, you can ask your question.
Okay, thank you, sir, and everyone for the nice initiative. We really enjoyed that. I am Shakal Roy. I graduated from BUET, Electrical Electronics Engineering Department, and now I am doing Masters in Ashrafur University, Department of Math and Science. My question is a bit related to my research, and many research I have already seen or studied. Where do I draw the line when I will refer a theorem or a known material or a known knowledge or a lemma without even understanding totally. This may sound naive and this may sound lame also, but I am asking because I have found that this is very much important for the students who are in school, college also. Should they memorize a theorem or go deep down to understand the theorem? Like many basic theorems. Like if I take two numbers and take their LCM and HCF, and if I multiply them, the product is equal to the product of the numbers. We know that many people memorizes that. We also memorizes that, but at a school level, what should we do? Should we focus on that part? And I come here in my research, in my own research, I am stuck at some point when I am not sure whether I will go deep down or just refer that theorem and build my own theorem. I think I make it clear. Thank you, sir.
Okay. So memorizing of theorem doesn't do you much good. It's to be avoided. Okay. At a lower level, there are some facts that actually help. You need some skills, and the students are not at a sufficient level where you can press reasoning on them. Yeah. But you can do that in simple ways. So, for instance, students are taught if A plus B is equal to C, then A equal to B minus C. A is equal to B minus C. All right. Yeah. So now you are just taught mechanically. You take the B on the other side, the plus B becomes minus B. Correct?
Yeah.
Okay. You could start off telling students at a very early level that here is an axiom. If two numbers are equal, if you add a third number to both sides, then they stay equal. In other words, if A equal to B, A plus C is also B plus C. All right? Yeah. So you start with that as an axiom. Okay? Now let's go back. A plus B equal to C. So you tell them that you can add plus minus B. Minus B is the number which by definition, when added to plus B gives you 0, correct?
Yeah.
Okay. So you add minus B to both sides of the equation. So on the left side, you have A plus B plus the number minus B. On the right-hand side, you have C plus minus B. But C plus minus B means C minus B, correct?
Yeah.
Okay, so A plus B plus the number minus B. Another thing among the axioms we have is the associative law. It doesn't matter which order we add numbers.
Yeah.
So what you do, you say, well, A plus B plus minus B. Let's add B with minus B. So that gives you 0. So you get A plus 0 is equal to B minus C. All right. So you understand just a few steps of reasoning. That explains why is it that if you take it to the other side, you get this. So I'm just giving you a very basic example. So now at some stage of the learning, when students are young, your brain is very plastic from young age to about 16, 17, 18, or even up to 20s, early 20s. Your brain is plastic, you're able to absorb a lot of things. If you learn bad habits, it sticks in you and it impedes your progress, right? Our problem is that a lot of the student talent is being destroyed by the process that they go through. A lot of cramming at early age, where you're not using your logical ability. And so when you are talking about your example, where do I stop? Do I memorize? Do I do this? Well, yeah, of course, there is a problem, practical problem you need to solve. So you have to get there before too long. But on the other hand, if this is something that is going to come up over and over again, you have to understand what's the theory behind it, right? That's where you actually make an attempt to understand what is the theory behind it.
Thanks a lot, sir. That sums up my answer. Thank you.
Okay. Okay, thank you so much.
Doesn't do you much good. It's to be avoided. Okay, at a lower level, there are some facts that actually help. You need some skills, and the students are not at a sufficient level where you can press reasoning on them. Yeah, but you can do that in simple ways. So, for instance, students are taught if A plus B is equal to C, then A equal to B minus C. A is equal to B minus C. All right. Yeah. So now you are just taught mechanically. You take the B on the other side, the plus B becomes minus B. Correct?
Yeah.
Okay. You could start off telling students at a very early level that here is an axiom. If two numbers are equal, if you add a third number to both sides, then they stay equal. In other words, if A equal to B, A plus C is also B plus C. All right? Yeah. So you start with that as an axiom. Okay? Now let's go back. A plus B equal to C. So you tell them that you can add plus minus B. Minus B is the number which by definition, when added to plus B gives you 0, correct?
Yeah.
Okay. So you add minus B to both sides of the equation. So on the left side, you have A plus B plus the number minus B. On the right-hand side, you have C plus minus B. But C plus minus B means C minus B, correct?
Yeah.
Okay, so A plus B plus the number minus B. Another thing among the axioms we have is the associative law. It doesn't matter which order we add numbers.
Yeah.
So what you do, you say, well, A plus B plus minus B. Let's add B with minus B. So that gives you 0. So you get A plus 0 is equal to B minus C. All right. So you understand just a few steps of reasoning. That explains why is it that if you take it to the other side, you get this. So I'm just giving you a very basic example. So now at some stage of the learning, when students are young, your brain is very plastic from young age to about 16, 17, 18, or even up to 20s, early 20s. Your brain is plastic, you're able to absorb a lot of things. If you learn bad habits, it sticks in you and it impedes your progress, right? Our problem is that a lot of the student talent is being destroyed by the process that they go through. A lot of cramming at early age, where you're not using your logical ability. And so when you are talking about your example, where do I stop? Do I memorize? Do I do this? Well, yeah, of course, there is a problem, practical problem you need to solve. So you have to get there before too long. But on the other hand, if this is something that is going to come up over and over again, you have to understand what's the theory behind it, right? That's where you actually make an attempt to understand what is the theory behind it.
Thanks a lot, sir. That sums up my answer. Thank you.
Okay. Okay, thank you so much. Honorable Prof sir is here. May I conclude now or continue or take some questions? This is Prof sir.
You don't have to take my permission or my consent. Ask Tanveer Bhai if he has time and if there are more questions.
I will have to. I will leave.
Happy.
I can leave. I can be here till another 10 minutes. So that's. I can't. I have to be doing something after 10 minutes. Yeah.
If anybody also wants to make some comments as well, I mean, not necessarily question. জসিমুজ্জামান স্যার যদি এখনো থেকে থাকেন উনি কিছু বলতে পারেন।
স্যার আমার আরেকটা ব্যাপারে আপনার কাছে জানার ইচ্ছা ছিল।
বলুন।
I talked to a couple of very brilliant math grad students from our country. They're particularly from Dhaka University and other top public universities. Except one or two examples, almost every student, they want to go to some grad school where either there is no qualifier exams or they have like super easy qualifier exams. So this is basically their mindset. And they have their reasonable explanation. Well, in our undergrad, we learned nothing. So my question is there any way we can change this sort of mindset? I mean, is it possible to change this sort of mindset?
Yeah, so there is of course, our problem is that our expectations are set very low, right? And there is no reason for it because just through the look at the performance of the students in Bangladesh Math Olympiad, we only started Olympiad business in 2003. Our score with the first Olympiad where we were joint last with Saudi Arabia, 3 points out of 120. And Mahbub Mujumdar took over in 2005, and then, the total scores jumped up. And then in the last 5 years, we beat India twice, all right? And we were placed 26th out of a list of 120 countries or something like 26th is the best we had been, 33, 40. So we're ranging between 25 and 40. So that's out of 130 countries. So that actually proves that our kids, there are kids who can be trained to do these problems which trouble even, as I said, some professional mathematicians. So that means our kids are able, all right? So now either at a lower level, I encourage all the kids to actually participate in the Olympiad process because that way you actually come across other kids and together you learn and you become better at this logical process. And that really helps, whether you win gold or not, or whether you win medals or not. This is a process that actually is very helpful. Now, what can happen is that students, as I say, you have a huge number of subjects you have to cover in a short time. So therefore, you try to take shortcuts and you get used to memorization, and you're not used to. There are certain things which are habits of mind. If you create habits of mind, bad habits of mind, which is memorize, and then you don't try to understand. A good habit of mind is you question everything. You start, why is this true? And try to understand. If this becomes a habit of mind, then you are in your way to success. Now, to answer your question about why is it that our students are looking for poor schools where they actually can succeed, part of the reason is that they see what has happened to their peers, and a lot of them went to good schools and didn't succeed, and therefore they think that maybe we didn't learn much and therefore will not do well. Well, that's a self-fulfilling prophecy in a way, yeah? So we need a change of mind. We need help from our administrators. We need help from our teachers. We need cooperative arrangements. We need We need to help this online map resources that I mentioned. You could do it at a certain level. You could do it for star students who are very capable. You could create online maps for them. You could do it for average students and for those who are actually struggling. So you could have these systems set up so that a student can self-learn to a great degree and overcome the limitations of the teachers.
Okay, thank you all for your nice time. Now it's time for closing speech. Before closing speech, I would like to read out a comment made by our Honorable VC Sir. The presentation is very valuable for us. At AUST, we should think about the possibility of introducing mathematics at the undergraduate level. Congratulations for the nice suggestions to Professor Saleh A. We thank our Honorable VC for these nice comments. Now, I would like to invite Professor Dr. Masum Billah, Chairman, Seminar Organizing Committee, Department of Arts and Sciences, Ahsanullah University of Science and Technology, for closing speech. Professor Masum Billah.
Thank you, Dr. Aminul. Thank you, Dr. Aminul. Assalamu alaikum, everyone. Respected keynote speakers, Professor Dr. Saleh A, sir, Honorable Vice-Chancellor, Professor Dr. Fazli Ilahi, sir, Ashrafur University, Honorable Pro-Vice-Chancellor, Professor Dr. Mahbubur Rahman, sir, Asst University of Science and Technology, and esteemed audience from home and abroad. First of all, I would like to thank the keynote speaker, Professor Tanveer, sir, for spending his valuable time and delivering the lecture. We, the AUST family members, are invited to him for the amazing speech. We are also grateful to our Honorable VC Sir and Pro-VC Sir for their valuable time and support. I also appreciated many more professors from many universities in public and private universities in home and abroad. I would like to thank all of our guests for attending the seminar patiently, attentively till late night in Bangladesh. I would like to mention here that our master's students of mathematics program were very enthusiastic and helpful in organizing this seminar. I appreciate and thanks them very much. Finally, thank you all again being with us. I hope your presence will be with in forever like this in coming days. Due to everyone's efforts, it has been an unforgettable experience and hope everyone takes away some wonderful memories. Thank you and thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.
Okay, thank you so much, Professor Dr. Masum Billah. So, anybody has any concluding remarks?
Thanks for organizing such a beautiful seminar.
Okay, Jashibuddin Bulsi, just a note for Tanveer. Bangladesh primary and secondary level math curriculum change hoche, and I think it is moving towards conceptual understanding, and I hope the university will follow through. Thank you.
Thank you.
Our head sir is still with us. Is there any concluding remark?
Okay, thank you. স্যার আপনাকে অসংখ্য ধন্যবাদ জানাচ্ছি, আপনি আপনার ভ্যালুয়েবল টাইম আমাদেরকে দিয়েছেন। তবে আমি স্যার এজ এ চেয়ার হিসেবে বা ডিপার্টমেন্টের চেয়ার হিসেবে আপনার কাছে একটা রিকোয়েস্ট থাকবে, যে সেটা হলো যে আমাদের বেশ কিছু ইয়াং ফ্যাকাল্টিস আছে, ভালো ম্যাথামেটিশিয়ান, তাদের সঙ্গে স্যার কোলাবোরেটিভ কিছু কি করা যাবে স্যার? কোলাবোরেটিভ কাজ আমরা করতে পারি?
হ্যাঁ, তো ওটা আপনার কিসের উপর ডিপেন্ড করছে, তাই না? মানে কে কিভাবে ট্রেন্ড হয়েছে তার উপর ডিপেন্ড করছে। in principle of course মানে কারো যদি মানে কে কোন কাজ করছে সেটা যদি আমি জানি বেটার, এবং আমি করেছি ঢাকা ইউনিভার্সিটি এক বুয়েটের এক গ্রুপের সাথে কাজ করেছি রিসেন্টলি। আমার ঢাকা ইউনিভার্সিটির এক ছাত্র এখানে এসে আমার ভিজিটিং স্টুডেন্ট হিসেবে কাজ করেছে, পরে ডেটা সায়েন্সে গেছে, এটা পেপারও বের হচ্ছে, আর ঢাকা ইউনিভার্সিটির সাথে করেছি। So I'm open to it, but you have to understand I have some limitations. You know, I can't work as quickly as I used to about 10 years back. So so that's part of the natural process of aging. So that means I'm a bit more constrained since I have to go here and there also. But in principle, yes. Yeah, sure.
Oh, thank you, sir.
Okay, thank you all. Our professor is with us. Is there any concluding remarks, sir?
No, thank you very much. But I mean, একটা জিনিস we need to mention that Professor Tanveer is also part of the another forum. যেখানে Dr. Shabbir Ahmed has started to bring together all the what do you call experts, America and elsewhere, যারা teaching or professional in high positions and who wants to, I mean, under one umbrella নিয়ে আসছেন, and Tanveer Bhai is also part of that forum where they want to transfer knowledge by way of such presentations and seminars, sometime in person and sometime via Zoom. And so I needed to mention this fact as well. Though it amra unilaterally or directly we have communicated with him because of my relationship or porichiti onar sathe, which span more than 50 years. And we are also very grateful to him, and hopefully, I mean, again, I'm inviting you all to another one that we are organizing possibly on February 2. And Tanveer Bhai, you will know him. He's Mohit Bhai, amader Mahbubur Rahman. And you can also join in that presentation. Thank you all.
Thank you so much, sir.
Thank you.
Many of our participants have requested to get the presentation slides as well as recorded video. So, sir, please send us slides.
Okay.
Okay. Thank you so much for being with us, and thank you for. We really appreciate your valuable time. Thank you all.
Assalamu alaikum, sir.
Alaikum assalam.
Assalamu alaikum.
Alaikum assalam.